Hello. Our project title is Smart Water pH Monitoring and Alert System. In this project, we are going to collect a grey water from households, as mainly classified as black water from toilets and grey water from kitchens, bathrooms, and laundries. Mixing improper disposal of these waters lead to environmental pollution and health issues. Monitoring the pH level of wastewater helps determine its quality and detect harmful substances. The smart wastewater pH monitoring and alert system uses IoT sensors near drainage points to continuously track pH levels. Mixing and improper disposal of these wastewaters lead to environmental pollutions and health issues. So our main concern is to solve this problem with this problem statement. Grey water can increase the risk of spreading bacteria and virus if untreated or reused improperly. Organic matter decomposition in grey water produces unpleasant smells within hours. Untreated grey water discharge pollutes soil and groundwater and harms aquatic life due to unstable pH. So our objective is to continuously monitor the pH level of wastewater in real time and ensure water quality is maintained within safe limits. This is the scope of the project. The scope of this project is to develop a smart wastewater pH monitoring and alert system that can continuously measure the pH levels of black and grey water in households. So let's get into the project and see explanation and building of the project. Our project includes sample collection from households and industries. And we need to continuously monitor the pH of the water by using a Arduino board and pH sensor. Alerts when the pH changes drastically and will do develop of the project. Our project does not include all types of phenomena like accurate prediction the water quality. It randomly predicts or it takes the average of the water quality. Continuous pH monitoring, real time measurement of wastewater pH using an electric pH sensor. Continuous monitoring instead of periodic manual testing. Wastewater treatment support, manual application of bleaching powder to neutralize abnormal pH. Post treatment monitoring to verify water quality improvement. Let's user friendly, it is an user friendly operation, simple interface for operators with minimal technical expertise, plug and play design for educational and pilot demonstrations. Let's get into our methodology. First step, pH sensor and signal acquisition. The pH probe is dipped in the wastewater sample. It produces small millivolt signal depending on the pH level. The raw signal is very weak, so it cannot be read directly. Signal conditioning, amplification and filtering, pH interface model, pH meter V1.0 amplifies the probe signal. It filters unwanted noise from the water. Output is sent to Arduino analog pin A0. Analog to digital conversion. Arduino reads analog voltage from pin A0 0 to 5 volt, converts it to digital value using its 10-bit ADC. Formula applied to convert voltage pH value. Fourth step, alert or decision making. If pH is outside safe range, example lesser than 6.5 or greater than 8.5, system triggers buzzer, LED display warning. So our output will be in LCD display, which displays the pH value of the water. System successfully reads and displays pH value between 0 to 14. Accurate representation after sensor calibration. Our methodology includes wastewater pH monitoring includes understanding wastewater characteristics, include selecting the pH sensor and interface module, designing the circuit using Arduino and LCD, installing the pH probe in the sample area, calibrating the pH sensor using standard solutions, Water quality treatment includes collecting wastewater samples for testing, applying bleaching powder for pH correction, observing changes in the pH after treatment, comparing pre treatment and post treatment results, ensuring pH values fall within safe range, documenting readings for performance analysis or architectural flow diagram. First, it collects the wastewater and we'll do sensor it using a pH sensor to check the pH value. It is displayed on the LCD display. After we do check with the pH value using the Arduino board, we can also do the responsive changes if the pH value exceeds. Like using a manual treatment, we can use a bleaching powder and use the HCl sensor to treat it after manual treatment. We can sense the pH value. Design use case diagram. We'll do design and use case diagram. In this diagram, we will use actors, user and operator technicians. This is the use case diagram used for our project. Class diagram, and is the sequence diagram for which we used in this project. Another sequence diagram. This is the example of the project, like how the workflow works flow works in the project. The major algorithms used in our products are sensor data acquisition algorithm. This algorithm continuously collects raw analog signals from the pH sensor placed in the wastewater. It ensures real time sampling of wastewater quality parameters for further processing. This algorithm reduces noise and fluctuations in sensor readings by averaging multiple samples. It improves the stability and reliability of pH measurements in a harsh wastewater environment. This algorithm converts the filtered sensor voltage into a meaningful pH value using a calibration based mathematical model. It translates electrical signals into chemical measurements. Another algorithm was threshold based decision algorithm. This algorithm is used when the pH value exceeds the range. Hardware and software used for our projects are pH sensor module, temperature sensor, which is an optional one. If you need to measure the temperature, we can use it. Water level sensor, it is also an optional hardware. Water quality pollutant, pH level, acidity, alkalinity, water safety status. And we have an buzzer and LED indicator. Implementation, testing and validation. Test system with different wastewater samples. Verify alert triggering accuracy. Compare results before and after treatment. Final deployment. Assemble components on hardware board. Ensure continuous and stable operation. Prepare system for real time monitoring. Important code segments. We do use this C hash code for C code for using the triggering pH alert system. This is an another code which continues. It is an output for normal pH. It do not. It shows the result as normal, which is 7.23. If the pH value exits within the range, it do generate an alert which shows the water pH level as 9.85. This is the final software simulations, which is made without using any hardware requirements, were roughly executed using Arduino.